video, we're going to prove the Pythagorean theorem using starburst. So this is actually going to be called the starburst proof of the Pythagorean theorem. So first, the Pythagorean theorem can only work and can only be applied to right triangles. And we use the Pythagorean theorem to figure out the side length of a missing side of a right triangle. So here we have a right triangle, and first thing we need to do is we need to figure out the measurements of two of its sides. So first we're going to measure this side or leg of the right triangle, and we're going to measure it in starburst. So I'm going to take starburst and I'm going to see how long it is. So when I do this, I find that this side or this leg of the right triangle is the length of 3 starbursts. So now what I'm going to do is I'm going to figure out how long this side is, or this leg. And I'm going to find that this leg is going to be 4 starbursts long. So with the Pythagorean theorem, once we know what these two sides are, we can actually use those to determine what the length is of our hypotenuse or our third side. And basically what we're going to do is if we know that this side is 3 starbursts long, we can actually make a square with this side. So if we were going to make a square and each side was 3, then that means that each of the other sides would also have to be 3. And if I fill this in, then that means that this square would actually have an area of 9. Not the best square, but you get the picture. So now what we're going to do is we're going to make a square with this side. So if this side length is 4, what do each of the other side lengths need to be? 4. So 4 along here, 4 along here. I'll refocus that for you. And so when I add in the rest of my starburst, I'll actually see that if I make a square with this side of the right triangle, I'd actually have an area in the square being full with 16 starbursts. So I'm going to go ahead and make a square. All right. And so I'm going to go ahead and take these out for a second and kind of sum up what we just found. So we found that, the length of this leg right here was 3 starbursts. And then we also found that the length of this leg here, right here, was 4 starbursts. And then when we created a square with this side length of 3, we actually learned that the area of this square was 9. And we learned that when we made a square with this leg of the right triangle, we learned that this square's area, or how many starbursts that could fit inside here, was 16. And what the Pythagorean theorem says is that if you take the area of this square and you add it to the area of this square, you will actually find the area of the square created by the hypotenuse. So let's go ahead and do that. Let's go ahead and take our 9 starbursts, orange starbursts from this side, and then let's go ahead and do this. Let's go ahead and take, so we had 4 sets of 4 over here. So there's 4. There was 8. And then we've got 8 more. So here we have our 16 pink starbursts and our 9 orange starbursts. So altogether, 16 plus 9 actually gives us, 25 starbursts. Should probably hold these in place while I do this. Just a thought. So when we go ahead and remove our 25 starbursts out, and we say that there's 25 starbursts in here, to figure out what this side length is, we have to take the square root. Because 25 was the area, or number of starbursts inside, and all we want to know is what each of these sides have to be. And we know that 5 times 5 is 25, so that means this side has to be 5. And when we look back, that's what we had. Put all these back. There was a 9. Put all these back. Here was our 16. Again, we would see that 1, 2, 3, 4, 5. It is a 5 by 5 square. And so that's basically what the Pythagorean theorem says. The Pythagorean theorem says that if you call this side side A, and this side side B, and your hypotenuse, the longer side, C, then what you will do is you'll find that if you take A and you square it, so if you take A and you square it, finding the area of a square created by side A, and you add it to B squared, so in other words, if you add it to the square or the area created by the square of this side, if you add those together, you'll actually get the area of this big square over here. So if you took your hypotenuse side and you squared it, when you add these together, you get this area. So A squared, this area, plus B squared, this area, equals C squared, or the area in the square created by